And this sign here is the Greek letter epsilon. So this is called, you typically hear this called epsilon greedy. Right, the E greedy. And the way this works, oops, I triggered the wrong thing. Sorry. So the way we can do exploration is really by making our policy a little bit random. Right, so if I'm only ever executing the optimal action, there's no exploration. But randomness away from the optimal action or the known best action currently is how we do exploration. And so the epsilon greedy action policy does this by choosing a greedy action with probability 1 minus epsilon or a random action with probability epsilon. So the greedy action is the action which has the highest Q value in the current state. So if you remember how we created the policy in LRTDP, or even value iteration, right? Our policy there was the greedy policy given the optimal value function. And here we're going to take the greedy action given whatever value estimates we've got so far. And if all we did was exploitation, then we would have probability 1 of taking the greedy action. But because we want to do some exploration, we're going to have only probability 1 minus epsilon. And then with that probability epsilon, we pick some random action. So yeah, more formally, our policy looks like this. So the top line here is the greedy action. The bottom line is the random action. So this is telling us that once I know what the greedy action is, I can assign the probability on the top line. And for all other actions, I assume that we take the bottom one. And the reason this extra bit is here, oops, okay, can't get rid of that. The reason this bit is here is because that's a kind of random chance of taking the greedy action. So what that's saying is that we've got probability epsilon distributed across the whole action set. So in fact, what I'm going to do, rather than blank this, I'm going to just exit that, play it again, because then I can draw on it more easily. So you can think about this. So this will be like some small probability. So we say epsilon equals 0.1. Then epsilon here is 0.1, and say we've got 10 actions. Then in each state, then this means that's the size of the action set. So that's 10 actions. And so here, what we're going to say is the probability of taking a random action is 0.1 over 10. So we're going to have 9 actions that have probability 0.01. And then this is going to have 1 minus 0.1 plus 0.01. And we're going to have 1 action, and we're going to have 9 actions. Right? Because one of the 10 actions will be the greedy action. Okay, so that's how our that's how our epsilon greedy policy works.
Is it epsilon here just a probability?
Yeah. Yes. So epsilon has to be between 0 and 1.
Thank you.
And if it's 0, our policy just does exploitation. And if it's 1, our policy is uniform random.